Good morning or good afternoon, as the case may be. Thank you guys for joining us on this Monday. I know it's the beginning of finals week for many of the students, so thanks for making the time to be here. For anyone who can't make it, we will be recording this session and we'll share it online after the fact. So we're here today to talk about the Dassault 3D Experience platform. I know that there's a lot of interest in it because I've been getting a lot of questions submitted from the students about it. So at long last, we have the right people here on the webinar today to answer your questions, to give you an overview of how it's going to work and how it's going to help you be successful with designing your rocket and managing the project through the life of the challenge. So it's my pleasure to introduce Al Bunshaft, who has been a friend of Base 11 since actually well before the Base 11 Space Challenge was launched, and is one of our biggest supporters and helped make sure that Dassault Systems is a Chairman's Circle partner, which is the highest level of partnership that we have with the Base 11 Space Challenge. So I'm going to let Al take it over and introduce his team and tell you a little bit more about our plans for today.
Super. Thank you, Christine. Hi, everyone, and welcome to this brief webinar to get you started with the 3D Experience platform. We couldn't be more excited to be part of this competition and part of this challenge. I'm a computer scientist and an engineer through my education, and the Base 11 team has heard me talk about my experiences working on real-world projects that really sparked my career. And I'm here to tell you that this space challenge is going to be an experience that you'll, I'm sure, look back on many years from now and talk about, because nothing compares to working on real-world challenges in a team-based environment with industry participating. And this is going to be an exciting journey that we all embark on together. We at Dassault Systems have been investing in STEM education and the transformation of STEM education in our country and in North America for at least 10 years now. We're strong believers in what I refer to as experiential learning, which is what I just said, real world problems in team-based environments. I'm fond of saying in the real world, the answer is not in the back of the book. And we're also committed to increasing the diversity of talent in the STEM world. Far too few women involved with what we do, far too few minorities involved with what we do, and there's no reason, frankly, other than access and opportunity, and we want to work to open up that access and that opportunity. And we're going to work with you on that and your teams as part of this space challenge in terms of your outreach and your marketing activities. This is also linked to the competitiveness of our country, our communities, and our companies. Both our company at Dassault Systems, we make the tools that are used for innovation, but also all of our clients as well. And for you, it's ultimately linked to the competitiveness of your states, your communities, and ultimately providing for your families down the road. The 3D Experience platform that we're going to talk about here is the latest delivery of our tools from Dassault Systems. It's a cloud-based, collaborative, and interdisciplinary engineering platform. It takes all of our tools and delivers it in an integrated platform. And our clients are around the world moving to this platform now. The Boeing Corporation, for example, last year announced their strategic commitment to the 3D Experience platform, and that's happening throughout the aerospace industry and other industries. Students will have free access to the 3D Experience platform, and in addition to what they might do with other individual tools, there are a lot of benefits to using the platform as a collaborative project management workspace, and that's what we're going to talk about here. You'll also have access to certifications for the products that we provide certifications for, SolidWorks, CATIA, our Abacus product as part of our Simulia simulation and verification product line. And you can also begin to think of the platform as a repository for your work. resumes as an 8.5 by 11 sheet of paper, I think are dead. And it's time that employers like ourselves want to see the actual work that you do, and the platform will help you do that, store your work, and keep it in a place that it'll be visible to future employers for you. So there's a lot of aspects of this that are very, very exciting. The platform brings together all the tools in a way that it provides new capabilities beyond what an individual CAD tool or finite element analysis tool can do. And that's what we want to talk about briefly here. Hopefully get you interested to the point that you'll start thinking about doing your engineering work on the platform. At a minimum, your captain and your leaders will need to get familiar with the platform, because all the teams will be required to submit their work to the platform for the judging and some other activities of the Base 11 Space Challenge. So with that as an introduction, we're thrilled that you've joined us and are listening to this. We're excited that we'll be working with you and hopefully collaborating with you through the process over this next couple years, we expect. And I want to introduce the Vice President of the 3DEXPERIENCE platform for the Dassault Systems company, Ramesh Haldarai. And Ramesh has joined us to take you through some of the key features, hopefully whet your appetite to learn more. And this will end with what the next steps are. So with that, I want to pass it over to Ramesh. The floor is yours, Ramesh. Go ahead.
Thank you, Al, and thank you everyone for taking the time. I'm Ramesh. I've been associated with the Base 11 organization for a while now, and I'm very excited to be here. Today, as you come together as a team to deliver against the Base 11 Space Challenge, you will notice that this is probably the first time that a big team is coming together to deliver on a real-world project. So with that in mind, I thought that I'll take some time to explain to you some of the issues that large teams face in the commercial world, and then what you could do in anticipation for some of the issues that you might face, and what you could do in terms of planning and in terms of tools that you use and in terms of the way you work, so that you're able to not only be successful, but also do it in record time. So with that, let's start with one issue that everybody faces when you're coming newly as a team together. So you might have people from various organizations coming together. They might have different skill sets. And of course, they have different perspectives of what they want to do in the project. So we need to be able to bring the team together in a way that doesn't create a lot of non-value-added activities. For example, one of the things that we notice is that teams tend to spend a lot of time attending meetings and understanding what is the status of the project and understanding what is the status of the issues. And in general, just searching for information that team members have created and trying to compare and correlate with the design work that they have done or manufacturing work that they have done. So one of the good ways that we can avoid some of these non-valued activities is to ensure that we all have a pre-planned way in which we work together, and we have a centralized repository where we keep all the information and keep track of each other's activities and the deliverables against those activities, and generally share ideas that are related to the project. Now, you might immediately think about things like Facebook, or if you're using some other tool out there, a chatting tool or a social collaboration tool, you might think of all these tools that will come in handy when going and taking a big project like this on an extended period of time. So similarly, what we have done is that we have tried to put together all the capabilities that are required specifically in an engineering and manufacturing project to ensure that you're able to cut out all the non-valued activities that we described. The first thing that we put together is a way in which the team can share a team dashboard with everyone. So imagine that you have a dashboard that gives you the status of everybody's work and the status of all the activities that people are doing, and the communication that you are having amongst the team and with the overall team in the overall project. So that's the first thing that we have tried to deliver in this 3D dashboard. And in the dashboard, as you can see, there are many widgets there. The widgets do different things. For example, one widget is called Swim, see what you mean. And Swim is kind of an ideation and a social collaboration environment. Think of it like a Facebook for the engineering environment. So you can come in and you can share ideas. And in addition to sharing ideas and sharing pictures of your ideas, you can also share engineering information. For example, you can directly share your 3D models that you might create, or you might share Excel calculations or your simulation files so that people can immediately visualize that. So when people share this 3D information inside, let's say, social collaboration environment, you can immediately visualize it in what we call 3D Play. So 3D Play is an environment where you can visualize the 3D geometry, and you can do comments and things like that. And this is especially important if different people are making different parts of the geometry, and you want the whole team to come together and see the entire geometry. So that's what 3D Play is about. 3D Drive is kind of a environment, it's like Dropbox, where you have a shared folder that you can instantiate in your Windows environment. And once you have the shared folders, you can drag and drop your files, whether it's be Word files, or it could be PowerPoint files, or any kind of document, or especially 3D information and drawings into the shared folders. Then that directly goes to the cloud environment in 3D Drive. So when you are in 3D Drive, once again, 3D Drive understands that these are CAD files. So if you had an assembly file and you had many part files in the assembly, when you copy an assembly file, it will encourage you to copy all the part files as well. So it's aware of the relationship between these files, the relationship between assembly files and CAD parts, and also the relationship in parts and drawing. So it becomes very easy for you to keep track of all the files. And of course, it does revision control. That means that if you change your file and you put a new file in, it will know that it's a new file and keep the new revision in the right place, and you can retrieve either the older one or the new revision. There's also a messaging capability similar to Skype. In Skype, just like we are doing a webinar now, we will be able to share information. But in addition to that, you can directly share your 3D geometry, and you can do real-time interaction between the team members. For example, when you have your rocket inside the platform, then you can rotate it, and when you rotate it, everybody will be able to see how you have rotated, and you can zoom in to a particular area, and you can start making comments that are coming from other people and incorporate those comments into your design. And you can start this session at any time. And in addition to just starting this session with the 3D Play where you're doing visualization, you can also put on a 3D goggles and you can start seeing things in virtual reality. So the entire environment on the dashboard is created to make sure that we have all the tools in social collaboration environment that is applicable for an engineering and manufacturing environment. So it's not just a general purpose social collaboration environment. It's specifically designed for projects like this. And talking about projects, there is also an environment where you can define tasks in a very easy manner, and you can share this task with the people who are responsible for completing the task, and they can submit their deliverables right there into the task and submit it for review and approval. So you can set up your entire development process as you're going through it, right from your mission statement all the way to your test results and the execution and your successful launch reports. So you could capture all the information related to the project in one place. So having said that, you also would be probably aware that the submission environment for the project is going to be the 3DEXPERIENCE platform. So if you manage to collate all the information as you build it, as you create this information, at the end, you just have to configuration control and say, this is the final version on the platform, and immediately you'll be able to provide that information to your coaches and people who are evaluating the project. So that's the advantage of it. So you don't have to, at the last minute, go around trying to capture all the information for submission. So that's the first thing. So how do we improve the productivity so that we are not bogged down by non-valued activities like searching and meetings and inordinate amount of coordination? The second is about the project itself. So when you're doing the project, you probably are going through multiple phases in your product development process. Of course, you're defining the mission scenario, what your rocket is going to do, and how far it's going to fly, and how fast it's going to fly, and how powerful it's going to be. And you're going to define all the mission and scenarios, and you're going to define the system architecture for the product that you're defining. Then you will go into detail, functional and logical design, where you're saying, what are the functions that we should have in this particular rocket? And what is the logic that is going to help these functions come together at the right time? For example, the timing logic and what kind of pressure should build up and what kind of thrust should build up in the rocket. So you're going to define the functional and logical aspects of the system. You probably are going to also simulate the flight path and do all kinds of different calculations in terms of thrust and nozzle calculations and all the aspects of the design. In addition to that, you're going to now allocate these different functions to systems and subsystems within the rocket. Then you go into detailed design and you do your CAD and mechanical CAD, and if you have any electrical circuitry or you're going to write some control software, you probably are going to put those aspects into place and you're going to complete the detailed design. And then you'll go through a verification environment where you're going to verify and make sure that the systems that you build are behaving according to initial calculation. And this is probably an iterative process. Maybe you will have some issues and you'll come back and fix it, and you'll retry this design again with the new changes. And you go through this until you're confident that when you make the final product, it's going to work as you intended it to. Then finally, you'll go through fabrication and probably build your prototype. Now, this is the traditional way in which every company probably builds a product, and this is called the systems engineering process. Now, the challenges in the system engineering process is the handoffs between these different stages of the process. So you would notice that most of the time you've got different people working on different stages, and you've got different skilled people, interdisciplinary skilled people coming together to build this entire system. And what happens is, if you're using, in addition to different people working on these different systems, if you have different tools that you're using, then probably something gets lost in translation. And this results in rework, and also that eventually makes the productivity suffer. So how do we prevent this? So that's the vision of the 3DEXPERIENCE platform. So what if we could have a multidisciplinary team who are focused on certain disciplines, but at the same time they get knowledge of all the other disciplines as well, and they're able to execute the entire process. The entire team is able to execute the entire process in a platform where you don't have to relearn software. You've got one software that you're using throughout. You're using different apps in the software, and also you're not translating or you're copying information across from one application to another. Once you have the data on the platform, it's accessible by all the different apps that are on the platform for scenario modeling or systems architecture or functional logical design or mechanical electrical software design and detailed design. And you can also perform your design verification and validation and fabrication simulation before you actually make your physical prototype. So the idea is, how can I make a virtual prototype that is encompassing of all the disciplines, and how do I mature it in such a manner I'm able to identify all the issues that might come later and then front load these issues so that I'm resolving those issues when it's much cheaper and much faster to resolve it in the virtual prototype. And this is also called a model-based approach. And the 3DEXPERIENCE platform is a model-based platform. and hopefully you'll be able to spend more time in actual design than thinking about what software you're going to learn and what data you're going to translate from which environment to which environment. So that will take away those non-varied activities, and you can learn one software, which is a 3D experience software, and you will be able to carry out your entire systems engineering process until you're able to fabricate and validate. So let's look at your specific project. So this involves multidisciplinary people coming together. You probably are, as a student, would be interested in learning all the disciplines. That's one of the aspects of this project. You'll probably be able to pick up mechanical aspects, the aerodynamics aspect, if there are any control and electrical wire harnesses inside, the control logic and the timing logic, and also if you're building control software, you probably want to pick up all the aspects of the software. So what the 3D Experience platform environment will allow you to do is focus on the actual engineering and not on the software. So the software, once you learn one user interface, it'll be seamless for you to go from mechanical to aerodynamic to electrical and software to control. And also throughout the design process, you're starting with what we call a low fidelity model, maybe just a bunch of equations that talk about the thrust and talk about the flight path at the beginning. And slowly as you mature your design, you go into higher and higher fidelity models. And when you are ready to fabricate, you probably have a virtual environment where you have defined your rocket exactly as a physical rocket would be, and you're able to conduct all your flight path studies on the virtual model before making the physical model. So that's the idea behind a model-based engineering environment. And this is the promise of the platform. And this is the opportunity for you to learn the process that commercial companies like Boeing and Airbus use today to develop much more complex systems. So once you learn the process and you're able to appreciate how you can do things much faster and better and of higher quality, then you are prepared for the real world where you don't have a second chance. You cannot recall a rocket once it's launched. So you have to ensure that whatever you're doing is accurate and works as intended first time right. So what is the process? What are the tools that are available to you? What are the apps that are available to you on the platform? There's an environment where you can define your mission use cases. You can define the detailed requirements. There's an environment to define all the functions that you will need in order to fulfill the mission requirements. The logic that is required can be defined using logical block models as well as physical models using differential equations and algebraic equations. Then once you have defined this low fidelity model, or sometimes called 1D model, you can simulate the entire product and see the behavioral aspects of the whole product before you start making your detailed design and detailed design in 3D and simulate it in 3D. And then once you're done with all this, the reports that will provide you traceability is just an afterthought, and you can automatically generate those. So what does traceability mean? It means that you had a certain mission requirements. For example, you want to achieve a certain height, and then you want to achieve a certain thrust during a certain time. Then are you really achieving that? So that's what it goes through the mission requirement at the beginning, and then what functions, in this case, the function of the aerodynamic function, and then the nozzle shape and nozzle fit and form, and then the timing of when you're going to combine your fuels, and all those things are directly correlated to the thrust and the height that you can achieve. So that is behavior modeling, and you'll be able to see that throughout the entire design process. Let's take a little bit deeper dive. So let's say this is just a simple example system architecture. Let me tell you that this is not a real architecture. It's just an example out there for you to get an idea. So let's say these are the systems and subsystems you design. So each system is like an object, and it interacts with another system using a standard way in which you're interacting. And they're all changing with respect to time. So for example, if I take the nozzle system, you see the nozzle is defined by these algebraic and differential equations. For example, there's an equation that relates what is the area of the outlet of the nozzle, and that is related to the pressure and the temperature, and you're able to see the thrust and the Mach numbers that is generated by a particular nozzle shape. So you might want to play around with your nozzle shape, and you might want to see what you're able to achieve in terms of thrust. So for this, you need to define your nozzle equations in the nozzle system, and then your other aerodynamic equations, for example, the thrust and how it relates to the flight path and the angle of launch and how you're able to simulate the overall drag of your entire aerodynamic simulation is done in the aerodynamic system. And that's put under real world conditions. You might consider a constant G, or you might consider varying G according to the height. And those are the systems that equations that you want to put in the system. Typically, you might be, compelled to solve all these equations manually, and that probably is where a lot of time and effort is spent. Now imagine that if you have the right relationships between the different equations, and you have the equations and you have made the model of the equation using the equations, then imagine the system can automatically solve it for you. And that's what the 3DEXPERIENCE platform does. So you have these individual subsystems, you make the equation, you make the models for the equations for those subsystems, and then you solve the system as a whole, where it's able to take all the equations at one time as a simultaneous solving, using a simultaneous solving method, and give you the overall behavior of the entire system. And once you have this, you can starting to plot what is the pressure drop, how is it related to the thrust, or how is for example, the fuel mixture ratio related to the combustion or the heat generation or the pressure generated. And you can see all the different variables you put inside, how they behave with respect to each other, and also with respect to time, and how this evolves over time. So that's the idea behind the analytical modeling or the 1D simulation at the beginning. So you understand the behavior of the individual system, you understand the behavior of the overall system as a whole, and you do sensory analysis, and you say, if I change the diameter of the nozzle, what happens to my thrust? If I change the fuel mixture, what happens to my pressure? And things like that. So that's the idea behind the analytical model. So this is probably going to be accurate, but it might become more and more accurate as you go through the development process. And there you start making your 3D models and your electrical models and your piping and your tubing and all the other aspects of your entire system. And you can start calculating the actual weight based on the 3D models and start calculating the actual inertia that is developed in the systems. And you can substitute back into the equations the actual values of the change in weight over time and the actual values of the inertia. And you do all this in the 3D environment and link that with the original analytical models you had. So now you've refined your model to become much more higher fidelity. You can also look at how you're going to manufacture this, how you're going to divide it into multiple parts, whether you're going to use fabricated parts, or you're going to use sheet metal, or you're going to use whatever manufacturing, or you're going to use 3D printing, whatever the manufacturing methodology is, you can try out all these things and figure out what will be the various fit and clearances between these parts, what kind of joints you're going to have, whether you're going to have riveted or you're going to weld it, or how you're going to make these parts come together. So that's all the things that you can do in the multidisciplinary design environment, either in CATIA or in SolidWorks. Then you start looking at flexible body simulations. Here you're seeing a nozzle that is changing shape because of the pressure developed during the flight. And because of this change in shape, it's going to have some interaction with the other systems, and it's going to change the thrust, and it's going to have an impact on how high you can reach. And it's also you can also look at things like how the temperature is distributed, where the stress and strains are, how you should make sure that they don't fail during the entire process, how much is the maximum deflection of these flexible bodies, and look at also the drag simulation when you're under various wind conditions when your rocket is actually flying in real life. So these are the simulation capabilities that are available, and that's done in Simulia, which is one of the apps in the platform. Sorry. Then you probably want to do some, what-if analysis and say, I'm showing an example of a simple bracket, but what you're doing in this bracket is you're looking at reducing the weight, because that's got a big impact on the truss. And as you're reducing the weight, you can look at what you can do to reduce the weight. You want to make sure that it doesn't fail. So you want to change in this case, the bracket and see it without a pocket, with a shallow pocket and the deeper pocket and the through hole. And you're going through these different design of experiments, if you will, and optimize all the parts in your design to ensure that you have the right shape. And the 3DEXPERIENCE platform could help you, in this case, 4 parameters into 4 values each, 256 iterations of the design under various conditions, and pick up what is the right design for each one of the components. So this is detailed design. We are optimizing each one of the components to get the right shape and the right function, to meet the right function of the product. Then you go into the manufacturing world, where whether you're 3D printing or you're going to fabricate it using traditional processes like turning and milling, you can simulate all these processes and make sure that you have the NC code generated, which can drive a NC machine in your shop floor, so you get exactly what you want in terms of manufacturing to the quality that you want. So this is done in a set of apps called Delmia apps for 3D milling and 3D printing and for lathe operations. So this can directly interact with the NC machine tool, and you can send the G codes from here to drive the NC toolpath and fabricate the product that you want. So you can do all kinds of operations, rough machining and finish operations. You can even drive a 5-axis milling machine. So these are apps on the platform, and it will work on the geometry that you create during your design process. So one of the interesting things with 3D printing is when you're printing metal, the metal deforms because of the stresses developed during the cooling process. And one of the things that you could do is you could reverse compensate on your part design and make sure that the shape that you get as an output is warping to come to the final shape that you desire. So you can reverse calculate all those things and make the design appropriate and get rid of the warpage that might happen in the 3D printing process during the cooling process. So let's summarize. So you have the platform where you're storing all the information, and there are a bunch of apps on the platform, and they all interact with each other without having the need to exchange files in different formats. So once you create the data in any of these apps, it's available to all the other apps. And whether you did system engineering at the beginning, and then you created detailed design using CATIA or SolidWorks, and then you went and did finite element modeling, and you tracked your tasks using Innovia app for project management, or you simulated the manufacturing using for milling or turning or for 3D printing, everything is on the platform, and you can be rest assured that the data will exist, and it's an enduring and a single source of truth, so that everybody can come and look at this information, learn from this information, give you feedback, and you can comment on it, and of course at the end use it for evaluating the entire design aspects of your project. So with that, I thank you for your time again. I'm very excited to work with you, and if you have any questions of the platform, please feel free to reach out to our team. Now I will let Florent and Al take over and talk about the next steps after this webinar.
Good afternoon, Florent speaking. So what you have here on this slide is what is coming in the next days and weeks. So as it was explained in the email I sent you during this weekend, we're going to work with you to onboard you on the platform and to get you to understand all the tools and all the analysis and simulation you can do with the platform. What it means that the first thing is that you're going to receive an invitation to connect to the platform. That's going to be in the next days. For 2018, we programmed 2 webinars at this point. One will be Friday. Each time is going to be around 1-hour webinars. The first one is Introduction to the Platform. So it's really live for you to use and be able to start understanding where are the apps, how do you use, how do you create your dashboard, as Ramesh explained earlier. And also next week, we're going to talk to you about project and data management in the platform. So project management to be able to follow up and to track your tasks, and to also see what are your deliverables in the short and the long term. So it will be very interesting for all the project leaders in your teams, but it's open to everyone. And data management is key for everyone. Whether you're working with the tools with the platform or you're not working with the tools in the platform, you will still have at some point to understand where to store data in the platform because it's a cloud environment, and how to do import of data. So this one is key and is programmed for next week. After that, we will resume in 2019. So what I'm going to cover, or what we're going to cover next year, we're going to talk about 3D modeling and drafting in the platform, what you can do, what are the basics to know. If you want to manage your requirements in the platform, we're going to talk about that. We're going to have a few presentation about model-based system engineering, which is what Ramesh presented. So for a set of equations that's going to model the basic of your rocket, of your system, how you can start from them, add more and more information to have a full model of your system, and how to link it to your 3D model that you can have in the environment. And we're going to talk also about manufacturing, FEA simulations. And one of the key elements that we see in those kind of projects is how to make sure that I'm working on the right version of the data, and how I make sure that no one else is going to modify one file when I'm working on it. And so it's collaboration tools and project management and product data management. We're going to cover that also. And each time, or if we need a specific date, we're going to have Q&A sessions throughout the project to help you and to support you to do that project. So this is what is planned. And for sure, we're going to, with Base 11, collaboration with Base 11, we're going to ask you some feedback. If you need, or if we need to have some specific trainings or specific webinar, we will do it in the course of the project. So that's coming out and for the end of this year and next year. So thank you for your attention. So to close the point, the seminar, I think Linda, to talk rapidly.
I think that we'd like to have some time for the attendees to ask some questions as well. So I want to point out to everyone who's on the webinar with us today that toward the bottom of your screen, you should have a couple of options. One of them is a Q&A box. That is an ideal place for you to enter any questions that you would like to have answered, keeping in mind that you have a captive audience right now of the leaders from the Dassault platform. And if you're having any trouble with the Q&A box, there is also a chat box, and you can enter questions there. So I'll give everyone a minute to start queuing up the questions you may have that have come up during this webinar. And while you do that, I'd like to turn it over to Landon Taylor, the CEO of Base 11.
Well, thank you, Christine, and good afternoon and morning for all of you amazing competitors for the Base 11 Space Challenge. The quick remarks that I wanted to make is I really want to encourage every single student and every faculty member that are part of the universities to fully adopt the 3DEXPERIENCE platform. And the reason why I felt it was important for me to come on the webinar and to encourage you to do this, this platform is being made available to all of your universities at no cost to you as a result of Dassault's sponsorship. And unfortunately, sometimes when something is offered without a cost, people don't recognize the value and you don't use it. And so I want to make sure that you don't make that mistake in this case. And so I wanted to share I came up with 3 reasons that I really want you three value propositions and 3 reasons to fully adopt this platform. It was me personally who really wanted to make sure that every single one of you get a chance to have access to the platform. And here's why. Number 1, it works. What I mean by that is I've watched and understood the Dassault's value proposition to all of the aerospace and space companies who have adopted their platform. As you might know, their customers include Boeing, SpaceX. Their customers include Northrop Grumman, Lockheed Martin. So these customers are entrusting their business to this platform. And one of the things that Ramesh shared with me when we were at a meeting with one of the universities is when you adopt this platform as a student, they're showing that you could actually end up being 50% more productive in terms of how you run projects than current companies today. And that's a big promise. But if you want to know more details about that, you can ask the Dassault team about that. And so think about if you have the ability to outperform industry and the seat that you're in today, think about what that will do in terms of your attractiveness to being hired by industry. Point number 2, or reason number 2, is that if you adopt the platform and become proficient, you may get hired, or you will be very attractive to be hired by both Dassault's customers as well as the Base 11 partners who've joined the Space Challenge. I will tell you in particular, SpaceX, one of their recruiters, when we shared with them that all of the teams will have access to this platform and that you will have the ability to build your own digital portfolio, meaning showing your work, the work that you've built while you're in this challenge, that recruiter said, Landon, that reason alone is one of the reasons why we want to become a partner, because we will then be able to see the students, what they built, and that's what we care about when we're hiring and recruiting, not just what their grades are, but we want to see what they built. And so make sure you find out how you use the platform to build your portfolio. So point number 2 is it increases your ability to get hired. Point number 3, I don't know how many of you are interested in entrepreneurship, but if you want to become the next Elon Musk, the next Jeff Bezos, this platform also will help you do that. Ramesh and I and Al and JP, part of the show, have been talking about the ability for those of you who want to think about entrepreneurship opportunities when you come up with new innovations while you're working on as teams, there's an opportunity with this global marketplace that's coming up that you could potentially ultimately participate in getting your ideas and projects off the ground as an entrepreneur. And if you have questions about that, you can pose them either today or another time. So those are my 3 strong reasons for you to fully adopt the platform. And we look forward to kind of seeing the results. So back to you, Christine.
All right, I'm going to let Florent answer the questions that are coming in.
Yes, so I see 2 questions at this point. So the first one, will there be additional resource we can use to learn the platform? So yes, we will have the webinar, but on top of the webinar, you will also have access to some training videos. And on top of that, you will have access to our online trainings. And those trainings are complete. So you will be able to learn specific processes or specific tools online by yourself. They're all self-paced. So everyone has access to that. And if you need to understand which training to follow, I will post some information about which are the ones that are most relevant depending on what you want to do. So that's also a beginning of the answer. The second question is there an online community to discuss or to ask some question or real-time problem solving? There is someone that is on a daily basis going to support the users and ask some questions, or if he doesn't have the answer, look for the right people that have the answer. So yes, we will be supporting you in a real-time basis, on a daily basis, because there's a lot of people involved in that challenge. So we will be supporting you on the platform. where it's going to be inside the platform. Ramesh talked about the swim community. There is one community that is already created called Space Challenge Q&A support. So this is where you're going to be able to ask some general questions. And if it's specific to your design or to your team, or if you need, or you're not able to share specific information with the other teams because the Q&A will be open to everyone, we'll also set up a specific community for each team where you can exchange, and you will be able to send us some direct information in there. So we are providing you a support system for the duration of the challenge. Last question that I see, will you have access to 3DEXPERIENCE on your personal device or on university-based computer only? So it is both actually. You will be able to install and to use 3DEXPERIENCE on your own computer, PC only, no Mac. And for the university, yes, the university will be able to install 3DEXPERIENCE on their in their labs, for example, on their institutional computers. Some of the university, we are already working with them, so I know it is installed and it's going to be available. Some of them, it may be new, so we may have to contact them at some point, or you're going to ask them to install them on a few computers, for example. But in every case, you will be able to install it on your own computer. If you have a Mac with Bootcamp, it will work, yes. So it's a Windows-based, but Mac and Bootcamp you'll be able to install 3DEXPERIENCE on that environment. So those are the questions I see at this point.
I have one question on behalf of the students, maybe including some of those who aren't listening live here. So if I'm a student and the email invitation comes through this week and I'm busy, I'm in finals, for some reason I don't pay attention to it, I go off to the holidays, I come back in January, and suddenly I think, I want to get on that 3DEXPERIENCE platform. I lost my email. What should they do at that point? They don't have the email, but they want to get on board.
So you have to let us know either through base 11, or if you have our email, you can contact us directly, and we will resend you the invitation, and you will be able to connect to the platform. Up to this point, the leader of the team or any students will not have the right to invite external people. We will invite the people to the platform. However, once you are in the platform, you will be able to manage your own data and share your data the way you want it or the way you need it. So just contact us and we will resend you the invitation. I see a new question. Is there a limit to how many team members can have on the platform? So at this point, we are going to invite all team members. I received all the team roster from base 11, and I'm set up to send all the invitations. And this is also why I sent the email on this weekend, is to make sure that I've got the right email for all the users. But everyone will be invited to the platform. It's not limited to a number of students per team at this point. The invitation, so the new question, when the invitation will be sent? We've got one last internal step to do. Hopefully Wednesday, you're going to receive the invitation, and if everything goes very, very well, maybe tomorrow. It's just a technical thing that you have to solve at Dassault, but you will receive the invitation this week. Everything is ready to be sent.
Excellent. All right. Well, we don't see any more questions coming through, so I want to thank everyone for joining us. And you can always find us on the website or at Space Challenge at base11.com if you have more questions that come up, and we'll make sure to get them over to the team at Dassault and get answers for you. So thanks everyone for joining us, and have a good rest of your week.
Thanks. We look forward to working with everyone. Thank you.
Bye.
Bye.